really excited to be here today to talk with so many other people who are interested in open source firmware and security, because this is a hugely important topic. And I think what we don't, if we have Bluetooth, there we go. In order to have security, we need open firmware. That if we can't read and audit and build our own versions of our firmware, we can't have security. I also think open firmware will eventually win. If we can install our own firmware, we can out-innovate closed source systems, and we can make things that customers and users will want to use and want to install. In a lot of ways, this is analogous to the Unix wars of the 80s and 90s. There used to be so many Unixes out there that were closed source and proprietary, but there aren't very many of them left. The Linux and other open firmware, open Unixes, were able to be customized and tailored to what people needed. And that became what they demanded on their servers. And as a result, it became the dominant server operating system. I think this same dynamic is in play in our firmware as well. As I mentioned in the Linux boot talk at CCC earlier this year, that we can use Linux and its device drivers to build a more secure, more flexible, and more resilient firmware. And that in turn allows us to have more innovation and faster iteration and hopefully better adoption. But as Windows Snyder said in her Hack in the Box talk last year, no matter how much we try to reduce our risk, there are dependencies we cannot get rid of. And nobody does this alone. We are all in this together. And we depend on our hardware vendors and our OEMs to make it possible for us to build these open systems. And there's a lot of good news on that front. These vendors are really starting to engage with this open source community. Companies like Intel are sending their people to Yeah, I'm so glad that Vincent and so many people from Intel are here at this conference to engage with the community and work with us on building open source firmware, because they're a key partner in this with us. They've also been responding to community pressure. As Vincent mentioned, they've relicensed a lot of things. The microcode updates had a license that was incompatible with free software, so they rolled out a change. And when they rolled out that license change, they also updated the FSP. And again, we really need to thank Vincent and his team for pushing this through, because this is the new FSP license. It was 10 pages of legalese, and now it's 3 bullet points of Debian-approved language that allows us to bundle the FSP binaries into our free software and redistribute them as part of products, as part of images, as things so that we can continue to build our open firmware. And as part of Intel's engagement, they have a talk about using FSP here. They also have a workshop later this week on building open source on top of UEFI. And again, Intel, thank you so much for coming to this conference. Other CPU vendors are also engaging. IBM listened to the community and released documentation on the Power 9 bring-up, which allows a lot of the firmware to be written in open source. And they're using something called a petty boot, which is a Linux kernel in the bootloader path to select what's going to run. And that sort of capability is what we want all of our systems to have. There will be a talk on petty boot here at the conference, so I'm excited to to hear more about that, because we share a lot of similar ideas in the Linux boot project. The RISC-V CPUs are also really exciting because this is a chance to have free hardware along with our free firmware. And the Sci5 company has released a Linux-capable SoC along with all the source for their bootloader. They've also worked with their silicon vendors to be able to release a lot of the documentation and for the memory controllers, allowing them to have a blob-free boot. And this is really exciting, and there are 2 talks on this topic later this week, one on the memory and one on using Core Boot with RISC-V. We also have larger consortiums starting to get involved. The Linux Foundation has adopted Linux Boot, as has the Open Compute project. At the recent Open Compute Summit, they introduced the Open System Firmware project, and Linux Boot is a key part of making this open hardware also have open firmware. We have 2 talks, actually we have a few more talks on Linux Boot, one immediately following this one, and then another one about deploying it at Facebook. And this is really exciting that open firmware is actually getting deployed in real-world systems. The other part that really excites me is that the BMCs are finally getting attention. A few years ago, a BMC vendor told me they thought it wasn't sporting to go after BMC vulnerabilities because everybody knew they were insecure. And that's really bad when you consider how tightly coupled the BMC is into everything in the system. It has connections into basically every security critical component. There are projects to replace the closed source BMC firmware with open source, and there are not 1, not 2, but 3 talks on doing that this week. And this is really exciting that finally that piece is going to get opened as well. Companies are also starting to look at how do we move our roots of trust into hardware for more protection. Google has their Titan project, Microsoft has their Cerberus, Apple has their T2, HP has SureStart, and in the free firmware case, Purism's working with NitroKey to make a Linux boot or heads root of trust. Chromebooks have been a place that have been also innovating in the roots of trust, and there's a talk coming up later this afternoon about how the root of trust is also used for debugging, and which is great for being able to develop your free firmware. As someone who does a lot of vulnerability research, I'm also really excited that hardware attacks are finally in scope. That this means that if you have to, hook something up to unused test points in a machine, or like Scanlime does, go through and voltage glitch them, vendors are finally paying attention to this sort of thing. Also, old-fashioned attacks of rewriting the host firmware are being dealt with by things like Intel BootGuard, which allows the system to ensure that the firmware is unmodified before starting the CPU. And I love the idea of being able to trust that only the desired firmware is going to be running. But this moves us to the bad news. That capability can be used by the vendors to lock down the machines and prevent us from installing our own firmware. This is not a new problem. This was first noticed back in 2015 when some ThinkPads could no longer support Core Boot. And it's really unfortunate that the best documentation we have on BootGuard comes from Alex Matrosov's reverse engineered work on it. We really need documentation on how this works. We need to be able to write our own BootGuard components. We need to be able to sign our own BootGuard firmware on systems that support it. We can use various things to jailbreak to get around bootguard. Hopefully the details on this will be coming out sometime soon. But like most things, bootguard has not had a perfect rollout. There have been vulnerabilities, but we shouldn't have to jailbreak our systems to make use of this. This is something where the vendors should be able to work with us to let us secure our own systems. And it's not just the host firmware, as Vincent mentioned. There are lots of other things inside the system that we need to be worried about. The management engine is, again, very overprivileged. Ron Minnick, who'll be talking later, gave a talk about how it's an entire OS in there, and that means it has potentially network accessible vulnerabilities. There was one found last year. There are also folks at PT Research found that a local attacker was able to get code execution in the ME, and this allowed them to bypass things like bootguard because they were able to circumvent that root of trust. We can, again, sort of jailbreak the ME. We can use Nicola Corona's ME cleaner to reduce the attack surface. But again, we shouldn't have to use these sorts of workarounds. There shouldn't be any secrets in the ME. There can be cryptographic keys, there can be things that it uses for attestation, but the code that goes with that has no reason to be secret. We need to understand what these things are doing, and we need to be able to install our own firmware there as well. And also, as Vincent mentioned, there are a lot of programmable systems inside our systems. Johanna Rutowska pointed out in her talk that this mutable state is really the enemy and creates a huge amount of complications for building secure systems. It's not just our NICs, it's our GPUs, it's our storage, it's our power supplies, it's our fan controllers, it's the front panels. It's basically anything more complicated than a resistor probably has programmable firmware in these machines. As White Quark put it, our PCs are really just several embedded devices in a trench coat. This is and we need to treat them like a distributed system. NIST has published some guidelines for how we can start to think about having these devices attest and verify what they're running. And most of these solutions end up depending on the TPM. And we depend on the TPM for a lot of our security, but it does mean we're putting a lot of eggs in that basket. In some cases, as folks from the Korean National Security Research Institute found, we can circumvent that because we're not interacting with it right when we come out of sleep. Folks, we've also known since 2011 that it's possible for a hardware attacker to insert locality overrides and circumvent things like bootguard. There have also been recent developments in terms of building man-in-the-middle attacks on the TPM hardware. And the TPM is yet another programmable microcontroller, and it has had firmware vulnerabilities that have weakened our security guarantees. And this is worrisome that we can't see what's going on inside of it. We can't debug this sort of thing because it's closed. It is this closed source system. And it's really hard to trust closed source roots of trust. If you're Google or Microsoft working on Titan or Cerberus, you probably have a pretty good level of faith in what's going on inside of it. But for the rest of us, what are we going to do? Decapture chips and try to read out what's going on? We need these vendors to work with us as a community to help us help them secure the system, help us understand what they're doing inside of there. And we own this hardware. We should be able to also own the firmware. There's a lot of reasons that we want to be able to change it out, and we want to be able to adjust the attack surface. Steph gives a wonderful security training in which she points out that your threat model is not my threat model, but your threat model is probably okay. We all need to be able to tailor our systems to the specific threats that we face and the specific responses that we want to be able to do. It's very different if you have a high touch, low touch, or no touch system. The responses are going to be different. Your laptop is going to need a different response than a lights out server. And we need to be able to tailor the firmware to our specific threats. I really like what the Chromebooks have done, where they've found a nice balance with user freedom, that if you physically disassemble it, you can remove a write protect screw and overwrite the firmware. Android has a similar thing, where you can unlock the boot ROM and on some devices, and it notifies you that, hey, this machine is unlocked. But it gives you the user freedom to explore and try out different things. And that freedom to innovate is really one of the core things that we want to be able to do in this community. So we can take an idea like Matthew Garrett's TPM TopP and turn that into a piece of firmware that gets recommended for crossing international borders in a fairly short period of time. We can take Adrian Porterfeld's suggestion and actually do experiments and try to figure out how do we make the security usable. And this really goes back to the first freedom. As Solomon defined it, this is the freedom to change the firmware so that our computers compute the way we want them to. And in order to do that, we need documentation. We need to be able to control sign-in keys. We need to be able to work with our hardware vendors to be able to make these systems compute the way we want them to. And I really want to thank so many of the folks who are helping to sponsor the conference, that it's really exciting to see so many of the big vendors, especially the CPU vendors, as well as some of the folks who are deploying open source firmware at sort of the hyperscale. Because I think together we can really build a much better system. We can build a more secure system, more flexible, and a more resilient one. And again, I'm really glad that so many people are here and interested in this. And I'd love to either take any questions or also chat with you during the week. So thanks so much, and hope you all have a great OSFC.
Okay, we have a little more time before the next talk, so we are, you actually can take questions. So are there any? Okay.
Hey, my name is Dimitar Tomov, and actually maybe the question is more toward Vincent Zimmer, but I think you can answer it as well, because I see you both made the case of usability. Vincent mentioned, hey, let's have the source code, let's keep it simple, let's have the API, and let's have the build tools. Let us allow you to build your firmware that you're going to run on your system, That's basically in a nutshell what you're saying. Allow us to have the signing procedures, the keys and all that. Allow us to have the documentation. And I think this is really the first step, but what I would like to hear about is how do you feel about making the case of, hey, we actually want customization. Let's not just focus on usability, have the tools, have the API. Let's actually say we want open source firmware because we want to customize, because we want to innovate. And I also think that what you also found out that open source root of trust, that's really the key to security, because how can you be secure if it's hidden, if it's closed? You need to have transparency. So what do you think about going in that direction, which is definitely harder? Let's talk about customization. Let's not just talk about usability. We want to build our own firmware. We actually want to customize the process, how we boot, how our machines work. Thanks.
Yeah, that's a great question. And that's very much why we want that first freedom. We want to be able to tailor it to our needs, that your needs are different from mine. Google's needs are different from Facebook's, which are different from a home user, which are different from some other cloud provider. The capability to build our own firmware lets us do that. I've seen in the Linux boot community, there's we have two different runtimes. Google has a Go-based runtime that suits their needs. The Heads community has a C and Bash-based runtime that suits their needs. And we can work together because what we need is support from the vendors to get the Linux kernel running. And once the Linux kernel is running, we can tailor it to exactly what we need. So I think the focus on customizability is very much at the forefront of this movement.
Okay, any more questions?
Hi, it was just a quick comment on Android. In most smartphones, the boot ROM will check the signature of the bootloader, and what you were referring to was when the bootloader checks the signature of the OS, user can usually talk to the bootloader to disable that, so to load your own OS, but you usually cannot replace the bootloader.
That's true. The code that's displaying that message, obviously, is much more difficult to replace. On some phones you can do it, but on a lot of ROMs you're stuck with the original.
So kind of as a follow-up on that, the reason why on Android we usually have those lockdown bootloaders because of the boot from checking the signatures is because they want to implement DRM. So they want to have a root of trust that the user cannot control so that they can provide the keys to decode the encrypted media. How do you think we can walk around in this situation? Because it's very unlikely that the majors are going to be fine with allowing this use case for users if it means that they can no longer lock down the media.
So that's a great question about how do we work with folks that want to know that the software that's running is unmodified, that that they can trust it in some way. And I think attestation has had somewhat of a bad reputation in the free software community because it typically gets associated with DRM. But I think we can use attestation for good. Like TPM top P is basically having the firmware attest to us that it has been unmodified. And I don't think there's a problem with having having a movie studio say they only want to run on to stream their content to an unmodified player. And with a good root of trust, you should be able to do that sort of attestation. It should be able to tell the server this is what is running, and cryptographically sign that quote. Using something like bootguard in measured boot mode has a similar sort of effect, that as long as the system knows that the hash of the firmware that was executed, you can make later decisions about do you trust that hash or do you not trust that hash. So I think it's compatible. We can have both attestation and free software, and if we need to lock things down for media companies, that's a choice that the users can make. It's as long as it's in the hands of the user, that's fine.
Any more questions? Over there.
You just hit the spot there with the attestation topic. About what you said, that it is connected to DRM and that it can be used for good and that it can be open source and attestation can go hand to hand. Actually, the problem with that was only exactly that we had a lot of close components, but there was now a common sense gathering that online attestation system that is open source can provide this kind of features. So the only thing we need actually is to only understand how the system works. Exactly what I mentioned about, we need access not only to be able to build the system, see the source code and modify it. We need to understand documentation, how it actually works. Once we can do that, online attestation system that is based on open source components, both hardware and firmware, can achieve what you said. Just wanted to mention that because it's really a topic.
Yeah, that's exactly right. That if open source attestation systems are a thing for good. MIT and Boston University's Mass Open Cloud project is using attestation to be able to attest that the firmware in a cloud node is unmodified, the configuration is unmodified. So when they hand it over to a tenant, the tenant can verify that the cloud provider is not trying to subvert the security guarantees. And that exact same sort of guarantee can then be extended to the users of that system. So I think, yeah, attestation built on open components where we know what's going into it, where we know what we are trusting and why we're trusting it, is absolutely a good thing to have.
Okay, we have time for 2 more questions.
It's just a follow-up on the attestation topic. Actually, I would like to put another use case on the table besides the DRM, which is probably a bit more debatable. From an industrial point of view, you have devices in the field which fulfill security or safety relevant topics as well. So they went through a certain certification process to prove that they do what they should do, and you maybe as a train rider would like to ensure that it's actually the case. So we also need to rely on the authenticity or the integrity of the firmware being run, while we still as an open source redistributor, like to fulfill the license compliance. So that the challenge is actually to be able to lock down the device to a specific function without locking down the software on the device to take the users away the freedom to change it. I mean, normally our users won't change the firmware because they have different things to do, like running a train, than changing the hardware. But still, the license has to be fulfilled. So this is just another use case where it's also been usable for the good, while it's still a challenge to implement a good pattern to fulfill the licenses of open source and specifically also of GPL firmware, in the right way.
Yeah, absolutely. Being able for safety critical devices to attest that they are running a known version of the firmware before they are allowed to perform their safety critical function is a wonderful use case for this sort of attestation, especially if it's built in open source where you can verify on reproducibly built open source. So you can verify, yes, this is exactly the code and the configuration that was installed on the system. It's definitely a way to improve this safety critical systems.
Okay, one last question. Okay.
If users have different security needs, maybe we also need to be able to tailor the attestation process to user use case, basically.
I'm sorry, I didn't understand that.
If users have different security needs, different threat models, and so on, maybe we also need to be able to customize the attestation process, like what is displayed to the user, how it works, and so on. Right.
And being able to trust what's being displayed on the computer screen is very difficult. In introducing TPM Top P, Matthew Garrett showed a mock-up where the system asked for a password. You typed in the password, and then it displayed a fake kernel panic. And he pointed out that malware that does this would be almost undetectable because we've all seen random kernel panics trying to mount disks. So having protected displays or some way to know that you could trust it becomes a key part. Dino from Square suggested that our phones actually should start to serve more as these sort of trusted display terminals for a lot of this, and TPM Top P takes that uses that.
Okay, thank you very much. Give it up once again for Trammell Hudson.
Thank you all.